Hello students, in this video, we will discuss about the stability of the allyl benzyl carbanions and carbon free radicals. Now, the example in this carbanion conditions CH2 double bond CH2 minus. So this is the compound A. Next, another compound CH2 double bond CH. Here, now I'm representing here this one is taken twice CH plus. Next, third case CH2 double bond CH taken thrice C plus. So these are the three conditions. So in these three conditions, we have to reduce the negative charge or electron density on the carbon. So in these given conditions, now resonance again possible in these all cases. Sorry, in these two. We are discussing carbanion. So negatively charged one. So in this negatively charged one, so resonance is possible in all cases. Okay. So again it is donate the electrons towards this negative charge, donate electrons. Here these electrons moving towards to that carbon side. So density is decreases on the carbon ion. Again the tertiary carbocation here, carbon ion is more stable than secondary is than primary. So due to resonance here again tertiary is more stable. The next after that the second example, the simple example we will discuss. CH2 double bond CH2 minus. Next CH2 double bond CH minus CH3 group. CH2 double bond CH bond CH3 bond CH3 minus. So in these cases, how to identify the stability of the carbon ions here? So the stability of the carbon ions majorly depends on in this case. If this one release the electrons, if these two groups release the electrons towards carbon ion. Now this group it is acts as a plus side. Here also plus side group. Here also plus side. So here electron density increases. Here also electron density increases. But in this case, it is donate the electrons to adjacent carbon. Now these electrons moving towards to this carbon atom. So here resonance or the plus sum effect is present or possible. So resonance is common in all cases, but electron releasing groups plus side groups increases more. So that's why here density increase, this stability decreases. So which one is more stable compound in these three? A is more stable than B. B is more stable than the C. So here also this one 3 to 1 means CBA. Okay, so these are the stability of the given compounds. The same like another conditions also we will discuss in this. Another example. If a benzyl carbon ion involved in the reaction, benzyl, these are the allylic conditions. Next one is benzyl carbon ion. CH2 minus. Two groups. Three groups. In these three conditions, so which one is more stable means again here resonance more in third case. Why? Because three groups attached to carbanion, this one donates electrons to three Benzyl rings. Now this one tertiary is more than the secondary, or if you want to write this one is ABC also. C is greater than B, B is greater than A. This is the stability order of the carbanions when these are attached to the Benzyl condition. Next, another example. CH2 minus compound B. Here OCH3 group and water group. OH group. So these are the four compounds given. In these four compounds, so which one is more stable? How to identify that? Here one OCH3 group is attached to the para position, means always plus M group is dominates more than the minus I. Next, one NO2 group is attached to the para position. Here minus M is dominates more than the minus I group. Next, here OH group is attached to the para position of this compound. Now here also again, first plus M influence more than the minus I. Next, here there is no group is present. In these given four options, so plus M and minus M. So which one withdraws electrons? The minus M group only withdraws electrons. Here plus M group increases the electrons. Okay. Now the plus M groups increases the electron density more, means stability decreases high. So B, D are the least stable compounds. C and A are the most stable compounds. In C and A compounds, which one effectively withdraws electrons means the compound C only effectively withdraws electrons. Why? Because minus M group is present, effectively withdraws electrons. Now C is more stable than compound A. The next after that in B and D conditions, OCH3 and OH groups. These two are the plus M. In these two, which one effectively release electrons means OH group only release effectively than OCH3. So B is more stable than the D. So this is the stability order of benzyl carbene ion. Benzyl carbene ion. So this is the one kind of example. So next, another one example we will discuss. CH2 minus, here one CH3 group, here one CH3 group, CH2 minus, here CH3 group. So these are the three compounds given. In these three compounds, which one is the more stable? How to identify? Then here one group is present, CH3 at a para position with respect to this group. Now here hyperconjugation more dominates than the plus side. Next, the second case, the same CH3 attached to the meta position. Here, resonance mesomeric effect is not possible. So, which one affects only plus side group only influence? Next one, CH3 attached to the ortho position. This position is ortho position. Now, here again, hyperconjugation dominates than the plus side. Now, hyperconjugation is always increases the density more than the plus side. That's why here AAC groups are always less stable than the B. Why? Because here inductive effect of the present B is more stable. After that, these two hyperconjugation is common. Then next to go through the inductive effect in these two cases also. Inductive group, which one is very near? This group is very near. It is increases the density effectively. So compared to this one, both increases in these two. C is effectively increased. Why? Because it is very near. 1 comma 2. But in this case, 1, 2, 3, 4. Distance increased. So now this one is more stable. A is more stable than the C. This is the stability order of benzyl carbanions. So this kind of problems also very, very important. Next, another one we will discuss in that free radical conditions. Generally, we know that free radicals. CH2 double bond CH2 free radical. This is compound A. Next, compound B, CH2 double bond CH taken twice, CH free radical, second compound. Next, third one, CH2 double bond CH taken thrice, C free radical. These are the three compounds. So in these three compounds, free radical means one electron is less, deficiency is present. So same as like carbocation here. So the third compound C is more stable than B. B is more stable than the A. This is the stability order of the free radicals. So the same as the free radicals, if you observe that phenyl ring conditions. CH2 free radical. This is a secondary condition. It is tertiary. Total three phenyl rings. Here two, here one phenyl ring. So in these phenyl ring conditions, which one is a more stable carbon free radical in this? So now just we will discuss in this case. Here one hydrogen atom. Here one hydrogen. So in this case, if free radical tertiary triphenyl methyl carbon free radical case, now the structure is a highly repulsive group. So the name of this compound is propeller structure. Propeller structure. So due to this propeller structure, repulsions more. Repulsions here. Repulsions increases. If repulsions increases due to the propeller structure, now the structure is equal to which one? Secondary carbon free radical. Secondary carbon free radical means the stability order is 2. There is P only. B is equal to C greater than the A. This is the stability order for free radicalities, exceptional case only. Exceptional case. Okay. So this one is the stability. Due to the propeller structure only, the secondary free radical equal to the tertiary free radical structure. So that's why these two are the equal stability compounds. B and C are the equal stability compounds. So next, another one we will discuss stability of molecules and ions. Stability of molecules and ions only. So next one, an example. CH2 double bond CH2 compound B. This is the another one. 1,3 butadiene. Third one. 135. That is 1,3 butadiene. It is 135 trihexane. Okay, in this case, which one is the most stable carbocation? So how to identify that? Just if you observe in the given three compounds, normally, if it is donate electrons, this one comes to here. If it is donate to electrons, this one comes to here, and this one comes to here. There are only one double bond. So if a number of double bonds increases is called conjugation. If conjugation increases, stability increases. Stability increases. So on the basis of this condition, which one is more stable now? C is more than the B is more than A. This is the stability order for the given compounds. Stability C, B. More the conjugation, more will be the stability of the compound. So it is the generally molecule it is. So for molecule, we can identify this kind of stability. The next, another example, simple one it is. RO minus, all oxide ion is phenoxide ion. So alkoxide and phenoxide ion, which one is more stable in these two? Always phenoxide only more stable. So due to resonance, due to resonance. So that's why here it is more stable. The next another one it is ion only, stability of the ion. Ro minus, Rc double bond O minus. So in these two, which one is more stable? Again, this one only more stable. Why? Because here this one also involving in the resonance due to resonance. Okay, due to resonance. The next another condition. in these two. In these two, which one is more stable? How to identify? Here also resonance possible. Here also resonance possible. But RCOO minus is only always more stable. So due to equivalent resonating structures present in RCOO minus. Okay. Next, another example. PHC double bond O minus RC double bond O minus. Now, in these cases, which one is more stable? How to identify that? 3 double bond OH here R group is present, here PH group is present. Now this one gives some more resonating structures than this one. Here also this one equivalent, here also equivalent. But when PH group is attached to this one acts as a minus a group, the alkyl group acts as a plus side. So if it is release electrons, this one withdraws electrons. Now here electron density decreases, negative charged one density decreases. So it is a most stable compound. So like this also we can identify the stability of the ions. Okay. Next, another one example. This is the one molecule. This is the other one. Negative charge on these two. So which one is more stable? That is also important. Now this compound is always more stable than this one. So the inside resonance also possible. Here also resonance possible due to negative charge. Like this possible. Conjugation, everything is possible. But why this one is more stable means inside there is 6 electrons present. Here also inside there is 8 electrons present. So 6 electrons means it follows 4n plus 2 pi electron system. 4n plus 2 pi electron system. But 8 electrons means it is following 4n pi electron system. 4n pi electron system means it is anti-aromatic compound. This one is aromatic compound. Which one is always more stable? Aromatic is always more stable than the anti-aromatic. So that's why here the above compounds, first one is more stable than the second one. Next, another one molecule. Okay, next is another example. Okay, students, we will discuss the remaining examples in the next video. Thank you.